What's up, my mathletes? Thank you so much for coming back to part 2 of graphing absolute value equations and inequalities. And this is Mr. Muscarella coming at you. So let's go ahead and get into our notes. If you haven't already watched part 1, be sure you go watch those because now we're on this. So part 1, we talked about the absolute value equations and inequalities and just some general characteristics about that. In this video, we're going to take a look at the transformations. All right, so we're going to have these terms here called dilation, reflection, vertical shift, horizontal shift. In the beginning, they're going to be a little bit confusing, but as we go through examples, you'll start to see those a little bit differently. Now, let's take a look at this A value, right? The dilation, we're going to take a look at the A value. So the A value is going to have to do with the dilation and the reflection. What we want to do is pay attention to two things. One is what direction the graph opens and whether that graph gets more narrow or wider compared to the parent function. So let's go ahead and take a look in Desmos here at this. So right now, we've got an A value of 1. Now, think about this. If you're waking up in the morning, what are you going to do with your arms? You're stretching out. So let's go ahead and play with this A value. Now, if I make the A value, say, 1.5, 1.7, notice what's happening with our function. Now, two things we're noticing. What direction does it open? It opens up. Our A value is positive. Now, if I were to make that more on the negative side, notice now it's opening down. So like the bird's wings, it's going to fly, and depending on which way we're flapping our wings. So when the A value is positive, we open up, and when the A value is negative, then we open down. So let's go ahead and write those two pieces here in that reflection part. So, and you can abbreviate this if you want. So if A is, I'm just going to write a little plus sign for positive. The graph opens up. And then if A is negative, I'm going to write a little minus sign. You can write out the word negative if that works for you, but that's where we're going to have up or down depending on the A value right there. So if A is positive, you open up. It's negative, you open down. Now, when we look at the dilation, so again, we're looking at narrower or wider, and when that absolute value of A was greater than 1, so we're looking at if we went from -1 to 1, and we thought about that in the number line, I want numbers over on this side that are bigger than 1, or over on this side that are smaller than -1. All right, so when I look at that in my graph, again, notice the A value is -4.5, so that's really narrow. If I look at the A value over here, that's like 3.2, 3.7, 4.5, it just gets more and more narrow. All right, so when we take a look at those pieces, the A value there, that's when the graph, when we take a look at that, it's going to be more narrow for that piece. So it's going to be more narrow, N-A-R-R-O, and it's also called a vertical stretch. So think about that like you waking up in the morning. So a vertical stretch. Comparatively, if the absolute value of A is less than 1, that's where everything gets a little bit wider. So we will have wider right here, and that's also known as a vertical compression. So those things, and sometimes you don't have to say the word vertical. You're just like, yep, okay, compression. So those are the ways the A value impacts the graph. Now this K value, let's take a look at this guy. So now we're going to look at two other pieces. One is going to be the K value. So that's the constant that is located outside of the absolute value stuff. It's not the A value, which is right next to it. It's outside of the absolute value blob. So let's play with the K value. So let me reset the A value here. So it's the same thing as our parent function. It's going to go all the way to just 1. Now the K value, so let's move the K value. And what I want you to notice is the direction it moves. Ooh, look at that. What direction it moves? Notice the sign of the K value. So that K value right now, it's +1, +1.6, 2.2. Notice it's moving up. Now, when the K value is negative, that shifts the graph down. So depending on whether the K value is negative or positive, will tell you which way to shift that. So when the K value is positive, move everything up. And when K is negative, move everything down. So that's how the K value impacts, then we call that a vertical shift. Now let's take a look at the horizontal shift part. So now we're coming into x minus h. We're taking a look at this piece right here, this blob that's on the inside. And depending on the symbol that is there, we're going to have to take a look at some things. So I want you to write down two things here. So one is going to be this first absolute value. So y equals the absolute value of x plus 2. And we put the absolute value bars around it. And then below that, write down y equals the absolute value of x minus 2. Now, each one of these is going to move slightly different depending on that piece. So when there's a plus sign on the inside, so right here, when we have plus a value, we're going to move that many spaces left. So on this first one, we would move 2 to the left. And similarly, if we have this version right here, where we have a minus sign in the middle, so now we've got x minus 2 right there, we're going to move that many units to the right. So that is where, in the beginning, it's a little bit confusing for some people. So we would move 2 to the right. All right, and you'll see that as you go through and play with these as we go through that. So if I make that h value 2, notice how that piece, it moved it over to the right. Now when the h value is negative, that's when we move over to the left, which is kind of confusing, right? Because the h value, it says negative 1.8, but when I look here, when I have that piece, so when you see a minus symbol inside the function, you're going to move to the right. When you see a plus sign in the symbols, and the reason why that's confusing a little bit for some people is because when you have x, the general formula is x minus h. So if you had a negative value, x minus negative 2, that's really, because that's our h value right there, is that negative 2. But we're like, oh, we don't have a double negative, bro. We would just write that as x plus 2. So that's where you got to be careful with that. And if our h value was just 2, we'd have x minus regular 2, which we don't have to do anything with. So that's why this gets a little bit confusing, but you'll see this and it'll become a little more clear as we play with some examples and you practice a little bit on your own. So anyway, that's it for this video. Thank you guys for watching. Be sure you come back for part 3, where we'll talk about general form, increasing, decreasing, and take a look at these 2 examples of the 4 we have to do, or of the 5 we have to do. Thanks for watching. I'll catch you later. Peace.